High Bay 1 at NASA's Jet Propulsion Laboratory, JPL, is one of the most sterile cleanrooms on Earth. NASA's extraordinary Big Mars mission, that was sent back in 2020 for hunting life on Mars, will have its parts attached here, and also the first probe sent to Europa, named as Europa Clipper, will also be brought back to this sterile laboratory room. As long as uncrewed missions keep going to space, their Frankenstein bodies will be attached piece by piece in this room. To sterilize the robots, the hardware is either baked, bathed in hydrogen peroxide steam, or wiped down with the same pure isopropyl alcohol used to clean open wounds. However, there's one bacteria that has managed to survive in this extreme environment. Well, you are watching Gateway to Knowledge, and stay tuned with us to know more about the superbug that can survive in outer space. Safr-032 is a radiation-resistant bacterial spore found only in spacecraft cleanrooms. Indeed, it takes its very name from its peculiar habitat. SAFR stands for Spacecraft Assembly Facility. The R is for the medium in which it's cultured. Safr-032 has been found in all of NASA's cleanrooms, from California all the way to Kennedy Space Center in Florida. Its spores have evolved a unique survival tactic where they can build up layers of cells to use as shields that in turn protect their DNA. Not unlike the way we slather ourselves with sunscreen before going outside to protect ourselves from UV radiation, endospores create a type of biological fortress until they're able to find a safer situation and can reactivate their metabolism. NASA is keen to keep these microbes off of its equipment. The agency's Office of Planetary Protection is tasked with making sure we aren't contaminating the entire solar system with earthly bacteria. Its guidelines limit how many viable microbes are allowed on a spacecraft before it's even granted access to the launch pad. The office was created to make sure that NASA observes the Outer Space Treaty, which is a legal document drafted during the space race. In other words, transporting viable microbes from Earth to places like Mars is off limits. Scientists whose missions need to comply with the law have been wondering whether space itself might kill off Safr-032, and so they decided to send it there. The Emist Experiment, which is shortly abbreviated for Exposing Microorganisms in the Stratosphere, was run out of NASA's Ames Research Center in Silicon Valley by the microbiologist Dr. David J. Smith and his team. As its name suggests, it was designed to expose a large sample of Safr-032, swiped from the Mars Odyssey orbiter before its launch to the stratosphere. Smith's team sent a balloon 32 kilometers above the Earth's surface for 8 hours, exposing pre-filled cartridges of dormant Safr-032 samples. In the stratosphere, conditions resemble the dangerous landscape of the Martian surface. It's extremely dry and cold, and there's less atmosphere to shield anything from getting blasted by cosmic radiation. The team was hoping to find out how many of the spores would reactivate after exposure to freezing temperatures, increased cosmic radiation, and UV radiation, something to which the Safr-032 is known to be especially resistant to. They were also watching to see how quickly the spores would deactivate. When they got the samples back to the lab after a couple of weeks later, they saw that 99.9% of the entire population was destroyed. Safr-032 has been tested in the lab repeatedly over the years, and scientists know that UV radiation can kill it if it has enough exposure. Because all of them died in the stratosphere, this predicts that most terrestrial bacteria would be inactivated within the first day on Mars if contaminated spacecraft surfaces receive direct sunlight. But an almost complete kill of 99.9% is not a total kill. Out of the 40 million Safr spores sent to space, 267 were able to reactivate upon their return, and while that's not very much given the starting number, it's what many of the remaining 267 had in common that is Smith confounded. A large number of the surviving 267 spores showed evidence of a very common genetic change called a single nucleotide polymorphism, or a SNP. For planetary protection purposes, resistant strains like Safr-032 pose an interesting problem. Scientists are learning how to kill them, and direct sunlight seems to do the trick. But, on Mars in particular, there are dust storms that sweep up the fine rusty regolith, coating robotic rovers like powdered sugar on a pancake. Over time those layers build up, and while the gentle breeze that is sure to follow can clean the spacecraft, it's not a guarantee that there won't be a coating of dirt just thick enough to protect the bacteria from the Martian sunlight. Bacterial spores are skilled, or you can say they are intelligent, at using material like particles of dust as life rafts to protect themselves, whether it's on a ship sailing the open seas of the Atlantic or those sloughed onto the surface of Mars. Perhaps the most complex issue in relying on direct sunlight to kill hitchhikers is that not all parts of a spacecraft will be exposed to sunlight. Bacteria don't just conveniently survive on the surfaces of things, but they can work their way into wiring and tiny microscopic crevices in the aluminum. Those, well hidden and permanently shaded in the unreachable areas, are the ones that Smith and the Office of Planetary Protection are most concerned about. Smith and his team plan on launching another experiment later this year, where other spacecraft cleanroom microbes will travel alongside Safr-032 to space. This time they plan on trying to better understand what these genetic swaps mean for the resistance function of these spores. There are several empty rectangular frames lining the walls some 50 feet above the medicinal white floor in the cleanroom at JPL. From Voyager to Juno, these colorful badges are the only eye-catching thing about this austere room, with the exception of a spacecraft. Each empty rectangle waits for its own mission. Perhaps one will tell us if life exists elsewhere in the cosmos, so long as we can be certain that our extraterrestrial find isn't a stowaway from our terrestrial world of wonders. We hope you enjoyed our video. If you have any suggestions or ideas, please comment them below. See you soon.